Okay, I think we'll go ahead and get started. My name is Ben Kickert, and I'm here with my colleague Maureen Baehr, who will be looking over the chat. So if you have your Pathable up, you can interact with her over there. The session that we will be presenting today is entitled Creating VR Learning Rooms with Wolfram and AFrame. As I'm sure many of you have also experienced during this time of COVID and quarantine, lots of things have changed. For our team, one of the things that we've been exploring a little bit more has been virtual reality, looking into the advancements that have happened over the last couple of years, and also looking at ways that, that we can implement it into some of the work that we've done previously. Because of our interest in the Wolfram platform, one of the things that we've been looking into is unique ways that we can use the Wolfram stack to create VR spaces. In our case, we're wanting to develop VR learning rooms that allow us to automate and simplify the creation of VR settings that can bring data in that you can learn if you were more of a spatial learner or a visual learner, as opposed to being on your phone for another hour or two. Excuse me. We want to give you a more interactive way that you can do that. And so we're looking to do that through a process involving AFrame, which we will talk about now. But before we do that, the first thing just to touch base on or to mention is the state of virtual reality and what's happening. And I feel that nearly every meeting or conference or speaker that I hear talk about virtual reality, every one of them says that, you know, this is the year that VR is going to explode. And I guess that I'm no different when I say that I think that we are at a tipping point. If we look at some of the big players, PricewaterhouseCoopers has said that nearly 23.5 million jobs worldwide will be using augmented reality and virtual reality by 2030. So there's an expectation that will be included as part of regular workspace engagement. We've seen VR meeting apps just in the months between March 2020 and June 2020. Again, due to quarantine, we've seen a tenfold increase in how meeting apps are being used. From a hardware and software side, we're seeing that market move from $6.2 billion in 2019 to $16 billion projected for 2020. And part of the reason I think this is happening is because we're starting to see a positive feedback loop. We're reaching a point where standalone headsets and PC-based solutions are more available or of higher quality. That's leading to more people adopting, which then leads to better game development, better app development. And as more people develop, more users become interested. So a couple things that are happening that are exciting for us. If you followed along in some of the news about VR, probably the biggest announcement is the launch of the Oculus Quest 2, which is a $300 unit that is an all-in-one. You're not tethered to anything, and you can have 6 degrees of freedom while you're using that. If you look at advancements on things like the Vive Index, what you see is a incredibly high-quality user experience that people are able to tap into using all of the graphics processing power of their units. You're seeing for the first time true AAA game development. We've seen that in Half-Life Alyx, which again contributes to that positive feedback loop. If you look at Wolfram and you look at the discussions that we've had about virtual reality in the past, there's actually already a body of work that exists that goes back for 5 or 6 years, if not longer. Probably the most notable one is the Unity Link that integrates with the Unity engine, allowing you to create 3D scenes and then export those as apps that can work on VR headsets. Pedro Francisco did an exploration back in 2016, which I find fascinating that it was 4 years ago, talking about ways that Wolfram can be used in that VR environment, about how we can use it, look at volumetric shapes, how we can interact with items and use VR. 4 years ago, his conclusion was it wasn't quite mainstream. I'm hoping to talk to him to see if he's changed his mind at all. Another link that I want to provide was a recent Wolfram language presentation that can be viewed on YouTube, going through how that Unity engine integration can work with AR and with VR. Now, looking at the options that have been out there, particularly the Unity engine, this is a separate set of software that requires a particular skill set to be able to integrate. You're having to work back and forth between the two units, between the two software packages. So what we wanted to look at is an implementation known as AFrame. Now, AFrame is going to be based on 3JS. It's a JavaScript library that allows you to create, using simple HTML, 3D scenes that can be both viewed on a laptop, which we'll do here, as well as on a headset. It's open source, it's community developed, it's free. So as opposed to having to use a separate software package, we've looked at AFrame as our option because we can automate and do everything in a totally text-based way, just using a code editor, and in our case, doing some automation with Wolfram. One of the things that AFrame works with is it has a lot of library add-ins, and so in addition to the main package, you can also include physics packages, look at object interactions, you can add environments, which we'll talk about today, as well as some of the controller integration for the different VR headsets. The strength is obviously that it's free. We'll take a look at the code. It's very simple to do. It's useful for the desktop, and the VR is a crossover. One of the challenges that we've run into, or some of the challenges, is that there's varying quality of the libraries and documentation. If you're comfortable in JavaScript and HTML, probably not an issue for you. But if you're looking for a turnkey solution, it might not be the best choice. We've seen also some significant changes in the framework and in browser implementation that have caused some of our previous working code to break. It's also dependent not only on an internet connection, but on browser functionality. This has been an issue as with the Oculus Quest, you're bound to whatever browser they put in there. And so if they change their render engine, it can cause issues with the implementation. So the first thing I want to do is look at a very basic AFrame script. Again, if you're familiar with HTML, this should look very familiar to you in terms of setting attributes, open and closing tags. Here we're opening an HTML document. We are giving it a title. We're importing the AFrame script, which makes everything else possible below it. Once we open the body, we simply say, we want an A scene, which is the code that AFrame uses, and we want the background color to be a light blue. Let's put a box in there, and we want that box to be positioned, and we give the 3 coordinate system for that. So your X, Y, Z coordinate. So -1 is going to be to your left, 0.5 is going to be up by ½ meter, and -3 will be 3 units in front of you. You can set the rotation, the color, and then simply close that tag. We do the same thing for a sphere and the same thing for a cylinder. And then we'll put a plane on the ground for us, close the scene, and we're done. Now, because all of this is HTML based, you have many options on where you can deploy this. You could simply export your HTML, put it up onto an FTP server, and it's ready to go in this case. But because we're at a Wolfram conference and we want to showcase the ways that Wolfram can be used, we're going to use Cloud Export. So if we click our link here, and again, this is the web-based version. We can actually go full screen, and you can see with just a few lines of code, we now have a 3D scene. If you were in your Oculus Quest or another VR headset, every direction you look, you could see what was going on and interact with the space as well. But simply taking existing HTML code and publishing it to the Wolfram Cloud as an HTML file by itself is not particularly useful. So what we wanted to do is look at some automation for scene creation. And so here what we've done is we've started creating some HTML chunks. So we start with a simple open, which we've already shown, and then we're going to have a simple close, just closing the scene and the body. In this case, we want to have a larger floor, so we create that manual element that we're going to include. But from the Wolfram side, one of the strengths of the Wolfram software packages are that you can randomize, and you can also intentionally place things very easily. And so for us, we can ask Wolfram to give us 10 random colors to add a little bit of variety to our scenes. Here's a bit of code that I have borrowed from Stack Exchange, and I'm thankful for that. But this essentially takes the Wolfram colors and converts it to hex so that we can implement it into our HTML. We also want to create random sizes. So in this case, we're going to create a simple scene with 10 random spheres. And so we ask Wolfram for those 10 random numbers. Same thing for our X coordinate position, our Y coordinate position, and our Z coordinate position. With that, using a string join, we can take all of that and create these units. So if you're looking for a randomized scene, you want to have trees in different places, you want to have different objects to interact with that don't have to be placed manually. With a few lines of code, we can create that, pull all of that together into our HTML, and again, we will publish that to the cloud. And so here you see your 10 random scenes, or your 10 random spheres. So our idea is to explore some of these options so that when we get into the VR learning side of things, we can automate things that are going to be useful for us. The next thing I want to look at is the intentional placement of objects. So let's say that you want to create a scene where you're standing in the middle and you can look around and there are things that are equally placed in all directions around you. Again, this is a generic example, but let's just take the numbers 1 to 15. We want those in a circle 4 meters around us and evenly spaced out. So using Wolfram, we'll calculate what degree each of those items needs to be rotated so that it faces the center of the circle. Using circle points, we can create our coordinate system that's going to go ahead and give us the left and right and forward and back coordinates, the X and the Z, and then we'll say we want everything to be 1 unit raised. Create the elements just as we did before, but in this case, we want to add a little bit more texture and flair. So we're going to take a 360-degree image that we've pulled off of the free site Unsplash. We want to export that up to the cloud so it's available for us. Add the code so that you can add the sky to your scene, and we can assemble that scene here. And so now using Wolfram, we're able to place all of those items in a organized and evenly spaced manner. The other option you can do is to create a hallway. This is probably the setting that we use the most, just because it's easier to interact with. And so we're going to use our random colors again, calculate where those things need to be, what is the depth of our hallway going to be, how far to the left, how far to the right, how far back does each item need to be placed, and which direction does that need to be rotated so that it's facing what we need. We'll create those objects again, essentially the same code that we've used previously. But in this case, as we're kind of adding more elements to our scene and to our work, we want to look at a few of those additional libraries that could be useful to us. And so in this case, we're going to look at the AFrame environment component, which allows you to import the JavaScript and then with a single entity, create a scene around you that is much more realistic than just having a blue sky and a black floor. We're also going to use AFrame's Extra, which allows us to create navigational meshes so that as we're walking up and down the hallway, you're not wandering in places that isn't useful for the user. So for that to work, we're going to update the opening of our HTML by adding the 2 JavaScript packages. We're going to define our environment. In this case, you can see that we're saying we want the environment to be the preset of forest. We want a relatively open play area so that nothing gets in the way. And you can set how many trees you want in your forest, and we want a flat ground. We're also going to create a rig, which is simply an entity that moves collectively. And so in our case, the rig that we've created will contain the camera, and some of our more advanced implementations, what we'll do is take that same rig and include our Oculus controllers so that you can interact with things. We also put a light within the rig so that if you're walking down a dark hallway, you get that effect of being able to see a few meters one direction or the other. I mentioned the navigational mesh, but in order to calculate that, we're pulling in on some of the strengths of Wolfram, saying, we know how many items we have. We need to make sure that the mesh that will constrain us gives us space forward and backwards, and that it's evenly placed. And so that can be used with that. We can then assemble that. And here again, this is more of a simple example, but now we can walk side to side. It won't let us move left or right. You can see the scene around us with the trees that we've selected. And when we reach the end of the hallway, we can turn and head back the other way. Again, if you were in a VR headset, all of that would be interactive as you move around. Now, the title of our presentation is VR Learning Rooms, and looking at color swatches isn't particularly useful for that. So instead, I want to share with you a little bit of how we actually use this as a way to provide a learning environment that is useful for people who are more spatially or visually oriented. This last slide, and we will upload our entire notebook to the Pathable site so you can use this. You will be able to open this slide, make the decisions that you want about your room, and then submit the entire thing, and you can create a VR world in a matter of minutes. But in this case, we're just going to call it a VR learning room. We're going to define a page title. We can decide how wide we want our hallway to be. Because in this case, we're going to be using images to interact with. I give users the option to randomize those images. So depending on how you bring those in, it might be more useful to have them randomized. And then I give you the option to either have this published to the cloud or published to your Wolfram directory locally. And so if you're doing something with videos, you're doing something with a lot of images, it might be easier for you to export all of this to your computer and then upload it to your FTP server. Or if you choose Wolfram Cloud True, it will publish and be available that way as well. So here we're giving users the option for the environment. I tend to like a very simple, light environment, and so I've defined my my properties and arguments this way. But if you want any of the presets, we used Forest previously, but you can try any of these out. Here's actually all of the options that you can change within your environment. So if you want to start tweaking things and change your lighting or change your shadows, this gives you the option to do that. But the real question, and the reason that the title of this slide is Content is King, is because we really want to be able to bring in information that is not only neat, but is useful. And so the example that I want us to look at is actually something that brings us here to a web seminar. Is the fact that we're dealing with COVID-19 and we need different ways to interact. And so the first thing we're going to do is just a simple image search for COVID-19 infographics. As those come in, we're going to resize those. And so here we have 10 infographics that have come into, that we will put into our scene. I've included a couple other ways that we internally have done other searches. And actually we have a presentation immediately after this one where we're really looking at other ways to find and source and utilize visual information and to turn unstructured data into visual information. But let's say that we want 2 images of these topics that we're interested in. This gives us the option to do that. Let's say that you want to search for multiple aspects of a search term. So my daughter is 11 and a huge Harry Potter fan, so she can look for her favorite characters and say that she wants a profile picture of them as well as the cartoon character version of them. And so if she does this search, you know, again, a couple presses of a button and she's created her own VR world where on the left-hand side is a profile picture of Harry Potter and on the right, we have the cartoon character. If you have a bunch of files in a folder, you can pull all of those in. Same way if you want a random subset of those. Now our code is getting a little bit more complicated because now we're having to deal with additional assets to our scene. So what this is doing is it's actually creating the images. It is then exporting it either to your local directory or to the Wolfram Cloud. But because you've already defined all the images, again, simply run this and it will rename all of your files and it will go ahead and put it either into your local directory or into your Wolfram Cloud account. Now, one of the things that's different when you start dealing with images and video is there is a need to preload your assets. So we'll look at what the code looks like, but essentially, let me pull that one out. But essentially, you're going to load all of your assets, list them as preload, so that when you actually open up your scene, and make sure that everything is in place before you actually run things. And so that is going to take the images that you've uploaded. So here you can see they're all in my WTC Wolfram WR learning room assets and have been renamed sequentially in terms of the images. Just like what we did, this is essentially the same code as what we have with the color swatches, but we're going to calculate all the positions of those images. We're also going to add the source name, which is simply going to call from the files that we created, so that we can use the anchor in the assets. Again, just like we've done before, all of these entities are now created. The program tells you where things are going to be placed. We've added to the height that it automatically adjusts for the aspect ratio of the image. So everything here is going to have a constant width of 2 units, and then the height is going to be based on the image itself. So you can see that that has been auto updated. We're going to add a page title to our scene, create our navigational mesh, pull everything together, and publish it to the cloud. So here you see our first VR learning room. Again, all of this is just coming in from a Google image search. But if you're one of those people who memorizes things by remembering where they're at in relation to things, being able to walk through this is a little bit more enjoyable than just sitting on the couch with your phone and scrolling through things. Now, I am aware of our time. I do want to see if we have time for at least a few questions. If not, I'll catch up after my next session in the chat bar. But I do want to show a few things of extra credit. These are not things that I'm sharing the code with. I'm happy to if you reach out to me, but a few additional projects. And so one of them that we've looked at is bringing in Wolfram 3D models. And so there you have your Triceratops and your teapot that we can use. I can leave that up. We also have, this has image interaction. And so in this case, we pulled in all of the sustainable development goals, and we've made it so that when you mouse over it, we auto-generated audio. So it simply says what the SDG is, but this could be anything. You could have a picture of Shakespeare and pull in a quote from him, but when you mouse over it, you're going to hear what it is, and you can see the interaction as things move up and down. Another implementation of the same code would be to take what you have, say you take a picture of a state, and when you mouse over it, it's going to tell you what the employment rate is. If you take the time and positioned everything exactly, you could actually have the image pop up in front of you and actually create those interactive displays. We've also done a video hallway that you can walk down, and just like with the images, you can watch the videos as they come in. So what's the conclusions and the next steps? My conclusion is that I think that VR is only going to grow, especially as we're looking for new ways to interact in a quarantine world or in a virtual world. We're seeing lots of development. We're seeing that positive feedback loop. Next, I think that the Wolfram stack, particularly in something like this, provides a good solution for auto-generating code, whether you want it randomized or whether you want pattern-based attributes. I'm showing it on how you can use this for AFrame, but this could be used for generating your own website or generating C code or Python. You can use the same idea if you're having to implement things in a different way. For us with HTML, it works well. We've looked a bit at how VR adaptations are coming along, and some of the things that we've talked to some of the people that we work with is how easy it is if you want to have a 360-degree video tour of your campus. Once you have the video, which is relatively easy to obtain, it's a single line of code that says a video sphere, close a video sphere, and you can do that. We're looking particularly at these alternative learning environments for people who are probably going to be more excited by having a VR headset on than they are scrolling through Google image search. So for us, the next steps, as we mentioned, I'm about to duck out of here and join our next session at 3 p.m., which is using Wolfram to find and analyze unstructured data. And so we'll look at everything from more advanced uses of image search, using some machine learning to help find the best images, automating Twitter and pulling in Twitter for information that can be utilized not only for VR learning rooms, but for summaries of unstructured data. And so you're welcome to join us over there. We're also going to look at ways that we can integrate what we've done into a multi-user experience, similar to what the work being done in AFrame by Mozilla Labs is. And then finally, the next things are to utilize more of the development data. The last 2 years that we've presented, we've talked a lot about what's happening in sustainable development. We want to be able to take that same interest and parlay it with virtual reality to get more people excited and interested in it. And then finally, we touched on it with our Triceratops and our teapot, but we do want to add a bit more of what Pedro actually looked at with 3D objects within Wolfram and how they can be used in a VR scene. So that is the end of my formal presentation. Within the next hour, I will upload it into our Pathable file list. And so if you want to check back, you're welcome to it. Welcome to use the code, adjust the code. It's there for you. So hopefully if you have kids or friends or family, they'll find it just as interesting to be able to do a quick search and create their own VR world. I know we've had a lot of fun with it. Looking at just some of the comments in the chat, thank you for that. Feel free to continue that. Again, I think that we're looking at a high school educator who could use this. Because of the way this is structured, we actually have, you can do the same thing with an API. You can do the same sort of thing with a Wolfram API or with a cloud deploy to where you could have either Wolfram code or Wolfram code in the back end so that all that your users have to do is create a search and the world will be created for them. So it's a lot of options with that. So thank you all so much for your time. I don't see any specific questions, but feel free to reach out to me and we'll go from there. Appreciate your time.